All right. So if you're coming into my channel, guys, for those YouTubers that are coming in to see about this antiderivative stuff, we have not done area under the curve. We have not done Riemann sums. So don't judge me when I just say, guys, just take the antiderivative of f of x because we haven't done Riemann sums. We haven't done area under the curve. All we've done is just derivatives. So hit up another or just look at one of my previous videos. I think I have Riemann sums in there. Or wait, wait 2 weeks and then you'll have Riemann sums. All right, here we go. So we're just doing antiderivatives, and it's the same stuff that we've been doing ever since notes 19 or notes 18, maybe even notes 17. I don't remember. We did a whole circuit on this. So we should be pretty good, guys. And you can read all these notes whenever you want to have a chance. Um, we say that f of x plus c is a general antiderivative or indefinite integral. This is called the integral symbol. And it says basically in math symbols that you guys are familiar with, what does this mean? I don't like that they use a capital F and then they tell you that antiderivative of f prime means that f prime means f of x. So pretty much all it means is this: integral of f prime of x dx equals f of x plus c. Now the dx does mean something. The f prime of x does mean something. But for now, we're just going to say this is where it starts and this is where it stops. So whatever you have in between the integral symbol or the elongated f and the dx, that's what you're taking the antiderivative of. It does mean something. So I don't want you guys to be like, little robots and like, oh, I don't know. I'm just going to put a dx because there's always a dx. Sorry, I needed to take a sip of my coffee here. It does mean something, guys. All right. So here are your general rules. And you guys already know this. If you have a general polynomial, you add 1 and then divide by that number, c, and then you put a plus c. If there are no limits, if there are no numbers in the upper or lower hand of that integral, that's how you're going to do all the time. All the time. Cool? Yeah, usually there's something called definite integrals, and we put like numbers here. Um, if you don't see a number, you're always going to put plus c. These are called indefinite integrals. Antiderivative of 1 over x, well, that you should know. The antiderivative of 1 over x is ln of x. And the only reason why we put an absolute value is because the domain of 1 over x is all real numbers except 0. So you put an absolute value to have the domain all real numbers except 0. Does that make sense, guys? Virtual class, does that make sense or no?
Can you repeat it?
Yes. If I tell you, maybe look, let me rewrite this so you can see it better. If I tell you what's the antiderivative of 1 over x, notice, remember, we're going backwards. So yes, you can say ln of x, but technically that would be wrong because we don't have the entire domain. The domain of 1 over x is all real numbers but 0. So how do I get the domain of all real numbers but 0? Like this, by putting absolute value of x. And now the domain is all real numbers but 0. And that's it. Well, ln x is only positive, but not 1 over x. 1 over x is everything except for 0. The domain of 1 over x is everything except for 0. You know what I mean? Every x value except for 0, because you can't divide by 0. But you can divide by any other x value from negative infinity to positive infinity. Yes or no? Or are you just saying that just so I can stop bothering you? No. Okay. And then these are just general rules, guys. All that means is that you're summing some stuff like x squared plus x plus 5 or something like that. So all that is just general stuff, nothing crazy. This means that you have a constant. You can always bring the constant to the front. So these are just general rules. And don't worry, they're pretty basic. So let's go ahead and get right into it. So look at example 1. And it looks like it's tough, but it's not. So look, all I'm going to do is I'm going to rewrite it where I have a polynomial. So integral 7x to the 4th plus 4x to the half plus, I'm going to bring that x cubed up, x to the negative 3 dx. Everything that you have between the elongated s and the dx is what I'm going to take an antiderivative of. So antiderivative of all that, I'm going to put the equal sign. Here we go. It's just a polynomial, so I'm going to add 1 to that degree, 7x to the 5th, and I'm going to divide by that number, 5. Nothing crazy. Plus 4x, I'm going to add 1 to this. So 1 is like 2 over 2. So that's going to turn to a 3/2. And I'm going to divide by 3/2, which is like multiplying by 2/3. Does that make sense to everyone? I'm dividing by 3/2, which is like multiplying by 2/3. Plus, and then I'm adding 1 to that negative 3 there. So x to the negative 2 divided by negative 2. And I don't have any limits or any letters or numbers on the integral symbol, so I always put plus c. Now I'm going to fix it. So here we go. 7/5 x to the 5th plus 2 times 4 is 8. So I'm going to write 8 over 3 x to the 3/2. If you want to put the x in the numerator, that's fine. Plus, or nope, not plus, this is going to be minus. Minus 1 over 2x squared plus c. And that's it, guys. Have I lost anyone? Virtual class, you guys here?
Yes.
Okay. Are you guys all right, guys? After Thanksgiving break, are you guys happy and everything? Sorry, I had to take another sip. All right, here we go. Next one. Evaluate integral of 5 over x minus 2x to the negative 13. I recognize this 5 over x is the same thing as 5 ln absolute value of x minus, let's see, 2x to the negative 12 divided by negative 12 plus some constant c equals 5 ln absolute value of x plus 2 goes into 12 6 times. So I'm going to write it as 1 over 6x to the 12th power. Maybe I didn't have to do that because they had a negative exponent in the top anyways. So you could have left it on the top plus c. We're doing okay so far, guys? All right. Here we go. We're doing example 3 now. This time they do want f. And you don't have to write the integral symbol if you don't want to. You can just go right into it. It says the derivative is 10 cosine x and f of 0 equals 3. So this is called an initial statement. It doesn't have to be initial, but it's a restricted equation. Like this is going to tell me what my c is. Chavez, what do you mean? I'm confused. You're going to do the antiderivative of that. So you're going to go f of x equals antiderivative of 10 cosine x is going to be 10 sine x, because the derivative of 10 sine x is 10 cosine x. And then I put plus c. And now, to find out what my c is, I'm going to plug in a 0, and the y value is going to be 3. So I write 3 equals 10 sine 0 plus c. So 10 sine 0 is 0, guys. So 3 equals 0. Plus c. Sorry, guys, I got hit. I mean, I didn't get hit. Yeah, I kind of got hit, but I felt it. And so now that I know that c is 3, I'm just going to plug that dude in right there. Or actually right here. So what's my equation? My equation is 10 sine x plus 3. Cool or not cool, guys?
Cool.
Cool. All right, here are some formulas. You don't have to memorize them because you already know them. I mean, you should. Remember that if you take the derivative of the right-hand side, you should get the left-hand side. The derivative of sine x is cosine x. The derivative of cotangent x is negative cosecant squared x. The derivative of cosecant x is negative cosecant x cotangent x. Notice that it's negative cosecant x cotangent x, but now they have this one as positive, so the negative is on there. The derivative of secant x is secant x tan x. The derivative of tan is secant squared. The derivative of cosine is negative sine. But notice since we're going backwards, the antiderivative of sine is a negative cosine. Now, okay, did I talk too fast? Okay. Now think about chain rule. We're only going to do the simple ones for now. Later on, we'll do the more advanced ones. Think about a linear argument for one of the trig ones. So let's say, okay, look, so side note, don't write this down, just listen, because I'm going to write formulas up in the top, so I need this space. So I'm going to erase this in a little bit. If I want to take the derivative of sine of 3x, don't write this down, just listen, guys, so you can understand the concept. What's the derivative of sine of 3x? Cosine 3x times 3, correct? So if I want to go backwards, look, the antiderivative of 3 cosine 3x is just sine 3x. Notice, make an observation. Like, oh, okay. So what if I delete this 3 here and I want to go backwards? Do you see that or no? Okay, here's what I'm trying to say. Yeah, okay. No, yeah, you are. No, yeah, you are. Oh, sorry. Look, check it out. Don't write this down again. Just listen, because I'm going to write a formula in a little bit. I want the antiderivative. I'll hook you up in a little bit. I want the antiderivative of sine 3x dx. I'll hook you up in a little bit. All right, antiderivative of sine 3x dx. Well, antiderivative of sine x is just what? Negative, notice that I'm leaving some space, cosine 3x plus c. If I were to take the derivative, I would have had a 3 here in the front of that sine 3x. Do I have a 3 in the front? How do I make sure that I don't have a 3 then? There you go. So is there a formula, is there a conjecture that I can make about trig with a linear argument? When I say linear argument, guys, that means what you have inside the parenthesis there. So yes, there is a formula, guys. I don't want you to be a robot. Some years I mention it, some years I don't even bother. As like these notes are very similar to last year's notes because I didn't want to type fresh ones. So last year I didn't even bother, but this year I am bothered because we're in a pandemic. So here we go. Here's your rule. So I'm going to do this one here. So sine and then a linear argument, ax, where a is a constant. A is a constant. Equals, you always do the reciprocal. Negative, because it's cosine. Oh, let me write it again. I don't like how I did it. Negative 1 over a cosine of ax plus c. I'll do one more. Integral of cosine ax dx equals 1 over a sine ax plus c. You can do it for all of them the same way, but I just decided to do those two. All right. Let's see if we can do one, guys. So it says, while the antiderivative of basic trig integrals is straightforward, don't forget about chain rule deal, only going backwards. Let's look at one in action. And of course, you no longer have to think because we have now formulas up there. But remember, I want you guys to know that this came from somewhere. So antiderivative. So you guys ready? They want f. And they tell you that f of 2 is 2. So what do you think, Viacana? What's antiderivative of sine pi x? Yeah. Perfect. And then I put plus what? Plus c. I'm going to find the c value. So how do I find the c value? I'm just going to plug in the 2. So 2 equals negative 1 over pi cosine of 2 pi plus c. And that's not extreme pre-cal, just a little bit. That's 2 pi right there. It's cosine, so my value is 1. So 2 equals a negative 1 over pi times 1 plus c. I guess you don't even have to do that. 2 equals negative 1 over pi plus c. And I know a lot of you guys are probably throwing shade that I'm doing all these steps. You don't have to do all these steps. So the c value is 2 plus 1 over pi. That's what the c is. Do not try and simplify it, guys. This is the exact value. This is exact. As soon as you take your calculator and you type that in, it is no longer exact. It's approximate because pi goes forever. So here we go. My exact function. I wrote that a little weird. F of x equals negative 1 over pi cosine pi x plus 2 plus 1 over pi. You guys did awesome. We just finished Turkey Week. Popcorn? No, I'm kidding, guys. There's no popcorn here. Godina is confused because she wasn't here. Don't worry, we'll catch you up. We'll catch you up. No, miss, we're gonna catch you up. You're gonna learn everything. Don't worry, you're gonna have fun. Everyone, we're having fun, right? Okay. Calculate the indefinite integral 1 over the square root of 1 minus x squared. That one's pretty basic. It's pretty straightforward. You probably haven't done calculus in a week, so maybe you don't recognize it. What's the antiderivative of that? Is it sine? Arc sine, the inverse sine. You can say inverse sine or you can say arc sine, but do not say sine. So I'm going to write sine to the power negative 1. You can also say the word arc sine, ARC with the sign on it, of x, and put plus c. And that's it. That's it. I just put that in there just to see if you guys remembered. No, I didn't trick you, miss. Bam. Left jab, right jab. Indefinite, yeah, we're gonna catch you up, miss. Indefinite means that the integral symbol, the elongated f, does not have any numbers on it. All right, so here we go. Here's a question from the UH. I believe the quiz is called 25, or the number is 25, but the quiz is called Antiderivatives. So they give you the second derivative, and they tell you f prime of 1, and they tell you f of 1. They want the original equation. So here we go. We're going to do antiderivative of this first. So we're going to do it twice, as you can see. So antiderivative of that is, let's see, 2x cubed over 3 minus x squared over 2 plus c. Get to there. They tell us what f prime of 1 is. F prime of 1 is 7, 6. So I'm going to plug that in. So I'm going to write 7, 6 equals 2/3 times 1 to the third power minus 1 squared over 2 plus c. And I guess you don't have to do that if you already can see it. 7, 6 equals 2/3 minus a half plus c. Common denominator. I'm going to multiply this guy by 2 over 2, multiply this guy by 3 over 3. I guess if you have a calculator, you don't need to do any of that. But we don't have a calculator right now, so we're just doing everything freehand. Let's see, 4, 6 minus 3, 6 plus c. 4, 6 minus 3, 6, that is 1, 6. And you can already see they're being nice to us. I'm going to subtract 1, 6, and I can see that I'm going to get 6 over 6, which is just what? 1. Now that I know that, I'm going to plug it into my f prime. So here we go. F prime of x is equal to 2/3 x cubed. Make sure that it looks like the x cubed is on the side. Do not make it look like it's in the denominator. You can make it look like this as well. You can do 2x cubed over 3 if you don't like that. Minus 1/2 x squared, just to be consistent, plus 1. All right, here we go. You guys ready? I'm doing another antiderivative because I want f. F of x equals, so I have 2/3 x to the 4 over 4. There's a little dot there because I'm multiplying. You don't have to do it like that. There's all different ways. Minus 1/2 x to the 3rd over 3. Put a little dot there because you know you're going to be multiplying those two. Plus x plus c. I can see that 2 goes into 4 twice. So here's what I'm going to have. I'm going to have x to the 4th over 3 times 2 is 6. Look, I'm not consistent at all. First, I do fractions, and then I put the x next to it. Now I'm just writing x to the 4th over 6. Does not matter, guys. Same thing. I just want to make sure you guys know. Minus, and since I already wrote x4 over 6, I'm just going to make everything just one nice fraction. X cubed over 6 plus x plus c. Okay, Viacana? I come back. They give me f of 1 equals 2. I'm going to put it right here so I can reference it really quick. So that's what I'm going to do. I'm going to write 2 equals 1/6 minus 1/6. It looks like they're being really nice to me here. Plus 1 plus c. The 1/6 cancel out. So 2 equals 1 plus c. So that means c equals 1. They're being very generous. So here's my equation. F of x equals x to the 4th over 6 minus x cubed over 6 plus x plus 1. And I look for that. So let's see. Let me zoom out. 1, okay, so the first one I would delete A and D. Just delete them. And then minus x cubed plus x. I think it's letter B. That's it, guys. How do we feel? Do we feel okay? All right, here we go. We got one more. Excuse me. A car is traveling with a velocity 24 meters per second. Begins to slow down at t equals 0. Okay, so I begin to slow down right at t equals 0. So they're telling me when to start. With a constant deceleration of this. So this is my acceleration. Find the velocity via t at time t. You guys ready? Okay, so here we go. Now, I actually was thinking about this too. I was stalling myself. All right, so I need to do antiderivative. So right now, all I know is this. A of t equals a -6, and it's constant, so it's always -6 during that time until we come to a stop. We still okay? V of t, what's antiderivative of -6? Well, instead of x, we're going to say what letter? I mean, I guess that looks like an x too, right? And then don't just say that. What else do I got to put? Plus c. But here's what I know at 0, at that moment. So I know that v of 0 equals 24 meters per second, right? So because I know that, I mean, you can already just plug it in, but if you don't want to just plug it in, just do 24 equals -6 times 0 plus c. So then c equals 24. So that goes right there. So here's my equation for velocity. -6t plus 24. And this will give me my answer all the time. Are you still okay, guys? And that's it. We're done. It says find the velocity via t at time t. This will give me my velocity all the time. Okay. Sorry, it's just you two here, so that's why I'm always like. Okay. All right. Find the distance traveled. If I have kids over here, I would be like, hey, you guys okay over here? But no one's over here. Find the distance traveled at the moment the car comes to a halt. All right. How do I do that? So we got to think of a game plan. Another what? Yeah, antiderivative, because that tells me my position equation. And if I counted at t equals 0, if I say the amount traveled initially at 0 is equal to 0, then I can figure out how much distance I have traveled. Now remember, we're just going to figure out how far I've traveled until I come to a stop. We're not going to look for our displacement like where we're at t equals past that. You know, we're just going to see like how long it takes for us to come to a stop. What is my velocity when I come to a stop? 0. So before you do anything, find where v of t equals 0. Find the time. Find the time where v of t equals 0. So I come back to the negative 6t plus 24. So I'm going to write negative 6t plus 24. That's my velocity. I'm going to equal it to 0. So you can move the 24 to the other side. It doesn't matter. Negative 6t equals negative 24. Divide by negative 6. What do you get? Did you say 4? I didn't hear you, miss. You get 4 seconds. It takes 4 seconds for this car to come to a halt. So now I'm doing my position equation. So here we go. X of t equals, and remember, we already know that x of 0 is 0. So my c is going to be 0. So I'm just going to say c equals 0 then. X of t, antiderivative of negative 6t. Negative, I mean, if you don't see it, guys, we'll do it like this. But if you want to, if you see it, you can immediately just write negative 3t squared plus 24t. I'm just doing antiderivative. And then plus c. But I already know that c is what? 0, because I started counting the distance as soon as the time was 0. So my x of t is a negative 3t squared plus 24t. I want to figure out the distance that I've traveled, so I'm going to plug in what? 4. Negative 3 times 4 squared plus 24 times 4. I don't think we need calculators. Let's see, negative 3 times 16 plus, I guess I would leave it like this for now, and then here I'll go ahead and figure it out. 16, 32, 48, so negative 48, 20, 40, 60. Wait, is that correct? Okay. Plus 24 times 4, 96. Because if I have 25 times 4, that's 100. And the difference between 48 and 96, I want to say that's 48. 48, 48, 8, 16, yeah. So I have traveled 48 meters. And now you can start seeing how beautiful calculus is, because you can do advanced physics with this. Is this cool or what?